Hi, this is Tom Herman with the National City Bank Data and Analytics team, here with some actionable insights for the bank product team in terms of our used car line of credit new offer that we're developing. So more specifically, my goal today is to present to you our top prospects that I would expect would engage with this new line of credit, accept the offer, or at least those who are most likely to do that. That's really the main goal today. But I also found a lot of interesting facts along the way, so I'd like to share with you just some interesting things about not only our current customers, but also those top 100 prospective customers who I expect would be most likely to accept our new loan offer. So we'll talk about the overall analysis, the approach, the methodology, briefly touch on that, talk about some attributes of our current customers, and then get into the models that I actually produced. We'll look at the various metrics in order to measure, the effectiveness of each model, how I arrived at that final model, and then of course take you through that final output, show you those top 100 prospects who I expect would engage with our new loan offer, and also those common characteristics of those top 100 prospects. So let's get into it. Okay, so before we get into the data, the modeling, and the results, which I'm sure you're very curious about, I just wanted to give you a quick peek under the hood here in terms of the approach and the methodology. This follows a data mining workflow called SEMMA, which stands for Sample, Explore, Modify, Model, and Assess. And what you see here are some of the pre-processing steps I took. I enriched our customer data with additional data that we purchased. I did some exploration of our current customers, looked at like call times and our customer ages, genders. And then, that really helped set me up for this modify step, which was determining, which of those many customer characteristics that we have are the most important in terms of actually predicting which of those customers will accept our next offer. And then I created 3 classification models to do that prediction. So the first one was a logistic regression, abbreviated here as GLM throughout the rest of my presentation, a tuned decision tree, and then a random forest. And then finally, at the assessment step, we take a look at each of those 3 models, see how they perform, look at their accuracy, look at various other KPIs in order to find the best model that we actually use for our prediction. And from there, we basically have our final model, so we can plug in our prospect data and let it predict our top 100 prospects, which I will share with you toward the end of the presentation. All right, so starting with the basic stuff, before we get into algorithms, models, predictions, let's take a quick look at some of the characteristics of our current customers, starting with age. So as you can see here, most of our current customers are millennials and Gen Xers, with ages falling between the interquartile range of 32 to 49, with a median of 39 right here. So looking a little deeper into ages, I wanted to see whether certain age cohorts had a higher acceptance rate than others. And indeed, the customers in the first and fourth quartiles, so over here and over here, in other words, our younger and our older clients have a much higher rate of acceptance than those in the middle. So you can see they're basically below the coin toss. You got 50-50 right here. The younger and older customers are, way higher acceptance rate compared to those in the middle. And as you can imagine, it turns out that age is going to be a very influential variable in predicting the probability of our prospective customers in accepting our offer. So just for good measure, I also took a look at our gender distribution in our customer data set. I was expecting to potentially see a higher proportion of one gender or another in our data set, but they're actually fairly evenly represented. There's not really a major difference between the propensity for males or females to accept our offer either, so I think that's interesting to know in and of itself. Okay, so final thing before we move on to the modeling section, I did take a look at our call durations, and since we don't have call start and end times for our prospect customers, I couldn't use those as potential predictive variables, but I still thought it'd be interesting to calculate the call durations for our current customers and see if there's any impact to whether or not they accepted our offer. And as you can see, customers who accepted our offer were on the phone with us a median 3 times longer than those who did not accept our offer. Kind of makes sense. You would think if they're accepting our offer, they're going to be asking about the details, asking buying questions. So it is somewhat intuitive, but I think it's important to understand this nonetheless. So, for example, the minimum call duration for a customer who accepted our offer was still 25 seconds. So I'm not sure what our call script or talking points are like, but if we can find a way to keep our prospects engaged with us for at least half a minute, that could slightly improve our chances for getting the business. So that's going to be a good sign if we can at least get them on the phone for half a minute rather than 5 seconds they hang up on us. So good sign for offer acceptance here. So moving on to the data modeling process, I used 3 different algorithms to create classification models to look at the data of our current customers, to learn which patterns lead to accepted offers, and use that to predict which of our prospect customers are more likely to accept our new line of credit. I also made these models as parsimonious as possible, which just means that I use functions to identify and use only the variables that were the most influential. So that reduced noise in the models, it made them more accurate and allowed them to run faster. In other words, that's what parsimonious means. The most important metric to evaluate each model is its accuracy, which is measured by how accurate it was at making predictions on the current customer data that it's learned from, but also against validation data that it hasn't seen yet. And the key is to achieve high accuracy on the training data, but it should also stay relatively consistent with the validation data, which means that it should generalize or perform just as well with unseen data. In this case, my random forest down here had the highest accuracy, but I lost quite a bit of that accuracy on validation. So my decision tree is actually looking much more consistent and has the best accuracy on the validation set out of these 3 different models. So this is a strong vote in favor of the decision tree model. So I just wanted to quickly show you a quick look at the decision tree itself here. So it basically shows the branches where it splits off and makes decisions. In this case, the past outcome is the most influential variable, where 8% of our current customers accepted the offer when they had a past outcome that was successful, which seems intuitive. If you have a past positive experience, it would reason that you're more likely to re-engage for another experience. So other important branches include last contact month, job, communication channel, and age. Okay, so we've seen the 3 models, their accuracy, and the actual tree produced by the decision tree. So now let's compare some additional key performance indicators and start to figure out which model to select that should give us the best accuracy with our prospective customer population. Here we can see a comparison of all 3 models using 3 important metrics: precision, recall, and F1 score. In this case, we want to maximize precision, which means that when our model predicts an accepted offer, it's mostly correct. This is important because we want to identify the top 100 sure bets in our prospective client data set. Recall represents the proportion of true positives to the total actual positives, and the F1 score gauges the performance of each model using a balance of both precision and recall. So an F1 score closer to 1 means that the model is doing a good job at both minimizing false positives and capturing most of the actual positives. So according to this chart, they're all very similar, but I think the decision tree wins out here with the highest F1 score, the best precision, and basically matched with the random forest in terms of recall. So this is the final piece that tells me decision tree is going to be the best model. These distribution charts show the accuracy and kappa ranges for the decision tree, and you can see the decision tree has a wider range of accuracy, which should generalize better to unseen prospective customer data. The random forest just shows a much tighter band, which won't generalize as well. So based on this and everything you've seen in the past few slides, I chose the decision tree as the best model to apply to our 1,000 prospective customers. So the moment you've all been waiting for. What you're looking at here are the top 100 prospects that the decision tree predicted would accept our new offer, sorted by highest probability to the lowest. Note, this isn't the complete file. I did hide some of the less relevant columns here for simplicity. But if you look at the right-hand column, you'll see that the model predicts these prospects have an 80 to 90% probability of accepting our offer, along with some other useful information like their household ID, age, duration since last contact, and more. So these are the first 100 prospects that our marketing department should consider engaging. So final item here, I just wanted to share some common themes about our prospective customers as we start to plan our marketing and research. And you'll see this in the actual data that I provided you with the top 100. But You can see here overwhelming preference for cellular phone use. So 93% of these top prospects show cellular as their communication preference. These people are relatively fresh. Most of them we've only previously contacted once, maybe twice. So that makes up the majority of our previous contacts. Unsurprisingly, most of them have had successful previous outcomes. So 79 out of 100 of these top prospects previously had a success outcome with us. They're highly educated. 82% had a secondary or a tertiary degree. The jobs, unsurprisingly, the most common you'll see here are going to be management. They're retired or they're technicians. And then finally, as I alluded to earlier in the presentation, really no major impact by gender here. So almost 50-50 split in terms of males and females who the model predicts or will accept our offer. So I hope you found this informative. Just to recap, I followed the SEMMA data mining workflow to sample and explore the data, modify the data for modeling, and then assess 3 different classification models to choose the best one, which turned out to be the decision tree, which I used to predict the top 100 of our prospect customers who are the most likely to accept our new line of credit offer. So all of that data can be found in the CSV file called Top 100 Prospect List, and you'll see the top prospects ranked from top to bottom by probability of accepting the offer. So if you have any questions, please don't hesitate to reach out. Thanks for listening and take care.